Imagine that this time I'm applying a force in this direction. And I say, okay, my angle in this exercise, my angle is this one. And let's say that this angle is 60 degrees. From where I'm taking this angle? From the principal axis, as you can see. Okay. So, do you remember what we used to do with vectors when we had angles? What did we used to do? What did we used to do?
We identify if it's vertical or horizontal. Solve for the
If, okay, we identify if the angle is vertical or horizontal. What type of angle is that?
Horizontal.
I'm choosing the vector or the hypotenuse, and I'm choosing this principal axis. This principal axis is vertical or horizontal?
horizontal.
It is horizontal. So in this case, it's a horizontal angle. Okay. What else did we used to do with the vectors?
Solve for x and for y.
We used to get the components. So if I do a projection of the two components of the force F, let's say that this force is 100 Newton. Okay? Easy numbers, easy numbers. Okay. So from this force, I can do the part of the components. Okay? I can project the components. So I'm gonna have two components. I'm gonna have a component that is going to be horizontal. In what direction is the horizontal component going? Right or left?
Right.
I'm going to draw this component. Is this direction right or wrong for this vector?
Left.
This direction is wrong because it should be, as you said, it should be left. Okay? So that direction is going to be wrong. The x component then is going to come in this direction. And I'm going to call this fx. The vertical component. The vertical component Fy. Where is it going? Is it going up or down?
Down.
It's going down. Okay? Okay, so my vertical component, I will do it in green. And as you said, this one is coming down. Question. Which one of the two? Which one of the two, Fx or Fy, is gonna be able to rotate the object? Only one component makes the rotation.
Fy.
Fy. Okay? The reason is because Fx is coming parallel to the principal axis. If it goes parallel to the principal axis, it doesn't create rotation. Okay? So Fx in this case it doesn't allow the rotation. In this case also, if y is going to be able to. So you in this moment, what are you going to do? First, you're going to discard the force you don't need, which in this case is Fx, because it doesn't make the rotation possible. And what are we doing with torque? We need to rotate objects. Okay, so the only force that is going to be important in this step is going to be Fy. It's going to be just Fy. So what is the force that matters? The one that makes the rotation possible. And because that's the only one that makes the rotation possible, we're going to get this component. We're going to find Fy. How do we find Fy? So remember, Fx, no need, because no rotation produces. Okay, it doesn't produce any rotation. But in Fx, we have to. Sorry, Fy, we have to. How can we get the component Fy? So we're going to be using trigonometry. How is Fy according to the angle?
Horizontal. Minus sign.
It is in front of the angle. So we're going to be using sine. So we say Fy then is going to be equal to the hypotenuse sine of the angle. The hypotenuse is the force F. So for this exercise, Fy is going to be force times sine of the angle. We substitute by the givens that are 100 Newton sine of 60 degrees. How much do you get?
86.60.
86.60. So now this is the formula. This is the value for the force that we are gonna be using. Okay? The only force that is actually doing the rotation. So first step that we do, we're going to discard the force that does not create rotation. The other step will be calculate the component that actually makes the rotation possible by using trigonometry. Okay, what else do we need to do? We need to work in a free body diagram. In a free body diagram, we show the forces acting on the object and the lever arm. What is the lever arm in this exercise?
20 centimeters.
Okay, those 20 centimeters are going to be converted to meters. Okay, so 20 centimeters, there are 100 centimeters in 1 meter. So we say that we get rid of centimeters with centimeters, and the lever arm is going to be 0.20 meters. Okay, so now we do the free body diagram. Okay, the size of the pencil. And this side over here, I have my pivot. And what is the force that is doing the rotation? Fx, F, or Fy?
Y.
Fy. So in here, now we're not going to include F, okay? We're going to include just Fy because it's the one that is doing the rotation possible. And also, we're going to include the lever arm, okay? The distance. In this case, the lever arm is D1, okay? Or dy, dfy, that'll be better, to be honest. Is equal to 0.20 meters, okay? So what is the value of Fy? We can make the substitution directly in the free body diagram. We say Fy equals 86.6 Newton, or 60, it's the same. Okay? Now, what do we do after? Now, after that we got everything in the free body diagram, we say, okay, now we can get a torque. So we say torque is equal to force times the lever arm. Because we're talking about Fy is going to be the lever arm due the force Y. Or just F and D is gonna be okay. If you don't want to be too fancy with the formulas, you can do it like that. And now all you do is substitution of the givens. We say torque then is equal to 86.6 Newton multiplying 0.20 meters
17.32 newtons per meter.
17.32 Newton
Newtons
meters.
meter.
Now, what type of rotation is Fy going to create? Counterclockwise or clockwise?
Clockwise.
Clockwise.
Clockwise. Because if those
Negative.
clockwise, it's going to be negative.
Negative.
And since this is the last answer, the final answer, you put it in a box. And if I say indicate the direction at which the pencil is going to rotate, then you have to make like the projection of the rotation, like this. Okay, so you can actually see the rotation if it's positive or negative. What is going to happen? Okay, let's try with this one. Let's try with this one. My pivot is always, in the case of the pencil, is always going to be the eraser, okay? So here I have my pivot. Now this pencil has a different length. This is a different pencil, okay? And this length is 24 centimeters, okay? I am applying a force that comes in this direction. Okay? My principal axis, if you don't have your principal axis, you always draw it, okay? It's good that we always have this reference. Now, I'm giving you this angle. And I say that the force is 100 Newton. And I call this force F1. Okay? From the two forces, from the two components, which one are you going to ignore? Fx or Fy?
Why?
Let's see. You're going to have this component in y, and you're going to have this component in x. In what direction is y going, up or down?
Up.
Up.
In what direction is x going, right or left?
Right.
Right.
Okay, so what component are you going to discard?
FX.
Fx. Fx doesn't work for us, okay? So you don't work with it. Now, what type of angle do we have? What,
Vertical angle.
horizontal or vertical?
Vertical.
The angle that we have is horizontal.
Horizontal.
It's horizontal, okay? It's touching. It's touching the hypotenuse, and it's touching this component, okay? And this component, if you make a projection of this component, you will see that it's a horizontal line. So it's actually touching horizontal and the vector, okay? So we say that this angle is horizontal angle. If we have a horizontal angle, how can we get Fy?
Right.
By using sine. If you don't want to do it like that, don't worry, okay? Don't worry. If you don't want to do it like that, don't worry. Take a look. This component from here, I can put it here. I can complete the triangle. I can complete the triangle, and now you can see the position of Fy. Fy is how, according to the angle, is it in front or adjacent?
In front.
In front of the angle. Okay, so you have two reasons to believe that Fy you have to use sine. First, because you have the horizontal angle, and second, because you see the position, okay, that is in front of the angle. So, two reasons. For Fy is sine because it is a horizontal angle, or you can say that Fy is also going to be using sine because it's in front. Two reasons to believe that Fy needs to be calculated by using sine. So we say Fy is equal to, what's the formula to get Fy?
Hypotenuse and sine of the angle.
Hypotenuse, sine of the angle. We make substitution and we say 100 Newton sine of 50 degrees. Then Fy is equal to
76.60 newtons.
76.
0.6 newtons.
Now, what do we do after we get the component?
Free body diagram.
We're going to make the free body diagram. I'm going to move this beside so I can make the free body diagram here. So my free body diagram must be the same length of my object. Okay, here I will locate my point P. Okay, and my Fy comes in this direction, upward, and has a value equals to 76.6 Newton. What is the lever arm? Already converted to meters is
0.24.
0.24. Okay, so here the lever arm in meters is 0.24 meters. Now we are able to apply the formula for torque. So we say torque is equal to force times the lever arm. Okay,
18.384 newtons meters.
how much is this?
824.
18.38.
1.
38 already rounded. Units are Newton meter. And now, what is the sign of the torque? Positive
Counterclockwise.
or negative? Positive or negative?
Positive.
Positive.
Can you please hold your pencil from the eraser?
Negative.
It is negative. Negative, my friends. That's why you always do the test with the pencil, okay? So if you hold your pencil from the pivot and you apply this force, this upward force, then the projection is gonna be like this, okay? So what rotation is that? That is clockwise. And if it is clockwise, then it is negative. So in conclusion, anytime you see torque with an angle, get the components and apply the same old formula that we have been using for torque. Remember, don't you think that just because a force goes down has a negative torque and the one that is upward is going to have a positive torque? No, it doesn't work like that. Okay? The direction of the force helps us to understand more or less how the object will rotate, but the type of rotation is going to be clockwise or counterclockwise. If it's clockwise, it's negative. If it's counterclockwise, it's positive. Torque, positive or negative?
Negative.
Positive. That's the rotation that it will produce.